Boyle's law. This is the same Boyle that we talked about when we talked about in chapter 3. We talked about the history of chemistry and atomic theory. Robert Boyle was the first chemist to perform a quantitative experiment. Okay, he was the first chemist to perform a quantitative experiment, and this is what he found. Okay, this is his first experiment from then. Uh, this is what we think of something as being common sense. Okay, something we think as being common sense. But at the time that he came up with it, it was something very revolutionary because they hadn't done anything quantitatively. Okay, so this is this is Robert Boyle for the first quantitative experiment on gases. Okay, he found that pressure and volume are inversely proportional if moles and temperature are held constant. Okay, so what does inversely proportional means? That if one goes up, the others goes down. Okay, and we know this. Okay, we know this. We know we take if moles and temperature are held constant, and we take a gas and we compress it, what happens to the pressure? If we make a gas smaller, what would happen to the pressure? It would goes up. It would go up. Okay. So that's something that we found. Okay. We also know that if we increase the pressure, if we decrease the pressure, the volume has gotten bigger. Okay. Something that is very simple to how we think about now, but at this point in time, it was not that. It was something that was very groundbreaking. So they tell you that pressure, this alpha, is means proportional to 1 over volume. Pressure equals volume times a constant. We don't really ever use that. Okay. Here's the big thing to take out of this: the Boyle's law equation. P1 V1 equals P2 V2. Okay. P1 V1 equals P2 V2. So the initial pressure times the initial volume equals the final pressure times the final volume. Okay. Now, as Thomas asked a while ago, do we have to convert? Yes and no. Okay. I'd probably say no and yes. Okay. It does not matter what units the pressure is in. Okay. If it's in kilopascals, you're good. Okay. If it's in PSI and PSI, you're good. But they have to be in the same units of pressure. Okay. So upon occasion, I might give you a problem in millimeter mercury and kPa. You have to convert. It doesn't matter what you convert it to. You can convert it to either kPa or millimeter mercury, or you can convert them both to atmospheres. That does not matter. Okay. So long as they're in the same unit. Same thing with the volume. If it's on liters on one side, it's liters on the other side. If it's milliliters on one side, it needs to be milliliters on the other side. There is no conversion unless they're not in the same units. Okay. Unless they are not in the same units. So our first example that we'll work out: determine the volume of a gas at 894 millimeters mercury if it had a volume of 1.52 liters at 2.3 atm. Where did my pink go? So there's our first problem. There is our first problem. This is the same. This is the same problem that we just did from our slides. So when I do this, and I know that some of us are going to be kind of lazy. I realize that. I don't want you to be lazy because this will get a little bit more difficult. Not a lot more difficult, but if you take your steps now and do it, with detail now, we're going to do this. Okay. So I'm going to know today is nothing but Boyle's law. So I know I'm going to have a P1, a V1. I like to written out like this: a P2 and a V2. Okay. Now it doesn't matter which ones are ones and twos. Okay. The P1 can be the initial pressure, the final pressure. It doesn't matter. Okay. As long as the pressure at that volume is on the same side. Okay. So when I'm looking for pressure, what units am I looking for? Give me an example of a pressure unit. What PSI? That's one. Give me another one. Torr, kPa, ATM, millibars, bars, PA. Okay, all those are what we were looking for pressure. Okay, so someone give me a pressure from this problem. What? From this problem. Give me a number. 894 millimeters mercury. Is that P1 or P2? It doesn't matter. It does not matter when you're working out. I'll make it P1 because it's the first pressure I see. So that equals 894 mmHg. Now, what is the volume at that pressure? No. You don't know. Because it says determine the volume of a gas at 894 millimeter mercury. So that's my question mark, okay? I could have easily made those the twos. It doesn't matter, okay? It doesn't matter. Now, what is my P2 in this problem? What's my other pressure? 2.3 ATM. And what is my volume? 1.52 liters. Now, if volume is in liters, if V2 is in liters, what's V1 going to be in? Liters. Okay? But now, we got a problem here, though, don't we? They have to be the same unit. It doesn't matter if you want to convert from millimeters of mercury or to ATM. That is 100% your call. I would convert from millimeter mercury to ATM. I like smaller numbers. That's my preference. So I know that for P1, I need to do 894 millimeters of mercury. So I'm going to convert that to ATM. So put that over 1 times 1 ATM over 760 millimeter mercury. I like smaller numbers. Okay, you could have just easily converted the ATM to millimeter mercury, and so you get, what do you get? You get what? 1.18. Okay, so instead, and that equals 1.18, and my unit there ATM. So instead of using this number, I'm going to use 1.18. I wrote 2 for some reason. ATM, yes, ma'am. Like, it didn't matter. I could have converted the other way around. I just like smaller numbers. 0.18 ATM. I have one variable, don't I? So now I'm ready to plug this into my equation. My equation is P1 V1 equals P2 V2. And so that is, my P1 was 1.18. My V1 is my X. That's what I'm looking for. P2, 2.3. And V2, 1.52. So how would I solve this problem out? I multiply, say that again, Gavin. Yes, Gavin's correct. I wanted you to say it a little bit louder. 2.3, because I'm multiplying away from the X first. Okay, 2.3 times 1.52 divided by 1.18. Now my significant figure rules apply, don't I? I'm multiplying dividing. When I'm multiplying dividing, I care about the fewest number of significant figures. So what's the fewest number of significant figures I have in my problem? 2. 1.18 has 3, 2.3 has 2, 1.52 has 2. Has 3. So my answer needs to have 2. And what do you get? 3.0? 3.0 what? What is my units of this? Liters, because that's what I ended in there. Okay? 3.0 liters. I'm sorry. I meant to go. Right? Any questions about that one? Second example. Determine the pressure of a gas that occupies 125 milliliters if it originally occupied 56 milliliters with a pressure of 1.03. Yes, ma'am. All right, so what is my original pressure? No, ma'am. My original pressure is not 125. 1.03. It does. If you put question mark, that's fine. Okay, but it doesn't matter which one's P1, P2 as long as they go with each other. My original pressure is My P1 is 1.03 ATM. What's my volume at 1.03 ATM, 56 milliliters. So as long as both of these are the twos, okay? Yes, as long as 1.03 and 56, they can both be the twos, okay? My P2 is what? And what unit is that going to be in? ATM. Why is it going to be an ATM? That's what my pressure was there in ATM. What about my V2? 125. So to solve this out, and now double check, my pressures are the same thing, my volumes are the same thing. So 1.03 times 56 equals X times 125. Now, before you solve this out, you can think to yourself, Boyle's law tells me if pressure goes up, volume goes down. So if volume went up, pressure goes down. So my volume went up, didn't it? Yes. So my pressure should do what? Go down. And it's by not quite a half, a little bit more than a half, correct? So 1.03 times 56 divided by 125 is 0.46 ATM, because that's what my units were. That's what my units were there. Okay, so 8.03 liters of gas is at 84.0 kPa pressure. What is its volume at standard pressure? All right, so what's my P1? 84.0 kPa. Once again, when I'm looking for pressure, I'm looking for kPa, ATM, PSI. What's my V1? 8.30 liters. What's my P2? What? Okay, so 1 ATM is standard pressure. Aiden is 100% correct, okay? I wouldn't want to use 1 ATM though, would I? 101.325. Standard pressure is 1 ATM, but it's also any of the conversion factors, okay? So I would use 101.325. So that's where I got that number from. And my V2 is what I'm looking for, and it will be in what unit? Liters. So did pressure go up or down? Went up, so what's volume going to do? Go down. So 84.0 times 8.30 equals 101.325 times X. I got what? 6.88 and 6.88 liters. So that one got a little more difficult because it's you had to look up standard pressure. All right, one last example. All righty, so once again, this is still Boyle's law. That's all today. So P1, V1, P2, V2. Whitey, what's the P1? Say it like you mean it. 1.0 ATM, very good. B-I-N-G-O. Honey, what is the V1, Thomas Lee Murray? What is the volume at 1 ATM? It's 3.60 liters. What's my P2? You don't know. What unit is my P2 going to be in? ATM. What's my V2? 1.25 liters. So you're going to expect, the pressure is going to go up by almost a factor of 3, correct? So 1.00. So the point to make this 21 degrees Celsius has no bearing on this problem. Times 3.60 equals X times 1.25. 2.88? That is wrong. What's it, Thomas? No. That's not my answer. What'd the question ask? You want in PSI. Okay, so now I could have done two things. I could have converted P1 to PSI. What I would probably have done was convert it to PSI when I'm finished, okay? So that's why that answer was not correct. So multiply it by 14.7 and give me like 30, 41. What? 42.3. Pay attention to what units they ask for, okay? And that's today's lesson, people. Any questions? I told you it's about as simple as